So welcome to our CT Day 1. Question 1 asks us to complete a table of values. So over here in question A, we're given the equation y equals 4x minus 1, and we're also given the following x values. So we merely take these x values, we plug them into the equation, and when we do that, we get our y value of -5. So our first coordinate pair is -1, -5. Plugging in the 0, we get an answer of -1 for y, so our second coordinate pair is 0, -1. And then we just continue doing that, plugging in each one of the x values that were given. So if we plug in an x value of 1, then we end up with 3. Plugging in 2, we end up with a y value of 7. So here is our coordinate pairs for our first table. Over here in question B, we're given a second linear equation, y equals 3x plus 2. And once again, we're asked to plug in a number of x values to give us a coordinate pair. So when we plug in -1 for x, we end up with a value of -1 for y. Plugging in 0 for x, we end up with 2 for y. And carrying on, we end up with the following coordinate pairs. Question 2. We're asked to identify the slope and y-intercept from each equation and then graph it. So here we have an equation, y equals -2x plus 1. So we're asked to use the slope and y-intercept method. So just looking at this equation, we can tell that the slope is going to be -2, and the y-intercept is going to be 1. We can plug in our y-intercept, plot it on the graph, and now, starting from here, we know that our slope is -2, so our rise over run is going to be -2, and our run is going to be 1. So we can plot in that second point, and then when we connect the two coordinates, we get a graph that looks like this. Question 3, we're given the equation y equals x minus 4. Well, the coefficient of x is 1, so that's our slope. And our b value is -4. That becomes our y-intercept, which we can plot here on the graph. Now we know that our slope is 1, so our rise over run is going to be 1 over 1. So here's our rise of 1. There's our run of 1. We can plot that second point and connect the 2 points, and that's what our graph will look like. In question 3, we're given the graph and asked to find out what the equation will be. Well, we can see that the graph crosses the y-axis at 1, so our y-intercept will be 1. And our slope is going to be rise over run. So what we want to do here is we want to find a point where the graph crosses in a nice, easy to recognize point. Okay, we don't want something that's halfway through one of these squares, one of these units. So we want to find something where it's very easy to read what the coordinate is. So if we go down 1 and over 2, down 1 over 2, we can see that each time it falls on an easy to recognize point. So -1 is a rise of -1, a run of 2 is 2. We put that into a fraction, we come up with a slope of negative 1/2. So if we know that our y-intercept is 1 and our slope is negative 1/2, then we can write our equation. In this graph, we can see that our y-intercept is negative 5. Now we want to figure out what our slope is. If we go up 1 and then across 2, we come to another easy to recognize point. Up 1 over 2. So a rise of 1 followed by a run of 2 gives us a slope of 1/2. Once we have our y-intercept and our slope, then we can write our equation y equals 1/2 x minus 5. Question 4 asks us to find the equation on the line with a slope of negative 2 that passes through the point 3, negative 3. So we'll use our equation y equals mx plus b, and we try and discover the various values. Our slope is negative 2. Now how do we know that? Well, here's our first point, our y-intercept, and here's another coordinate point where it passes evenly through a square. These are points that are easy to recognize. So if we figure out what our rise over run is from here to here, we'll know that our slope is negative 2. So here we go, a rise of negative 2 and a run of 1. Negative 2 over 1 gives us a slope of negative 2. Now, once we know what our slope is, and we have an x value and a y value, we can take what we know and plug it into this equation. So we know that one coordinate point where y equals 3, x equals 0, and our slope is negative 2. So if we plug in these values, negative 3 for y, slope of negative 2, and an x value of 3, then we can solve for b. With a little simple algebra, we come up with a value of 3 for b. Once we know that the value of b is 3, and we know that the slope is negative 2, we can write our equation. Find the equation of the line with the slope 4 that passes through the point 4, 8. Once again, we'll use y equals mx plus b. We know that our slope is 4. We're told that. And we're given 1 point, 0, negative 8. So we have enough information that we can plug it into a y equals mx plus b form. Our y value is 8. Our slope is 4. Our x value is 4. And we're solving for b. Once we have a value for b, we now have enough information to write our equation. B is negative 8. Slope is 4. So we can say that y equals 4x minus 8. Find the equation on the line passing through the point A is negative 8, 6, and point B is 4, 0. Now in this case, we're not told what the slope is, but we have enough information to figure out what the slope is. by using this formula here. So we'll take these values, we'll plug it into this formula right here. And when we do that, we end up with a value of -1/2. So this is our y1 value right here, 6, and this is our y2 value. So 0 minus 6, there we go, 0 minus 6 over 4 minus -8, that's that right there, results in -6 over 12, which reduces to -1/2. So that's how we use this formula to come up with the slope. Once we have the slope, we now have enough information to plug it into the y equals mx plus b form. So we're going to use one of these points. Let's use this one. It's a little bit simpler. So we know that the value of y is 0. The slope is -1/2, which we'll put right here. Our x value is 4, and we're solving for b. So when we finish solving for b, we end up with a value of 2. Now we have enough information to write our equation. Our b value is 2, our slope's -1/2, therefore our equation is y equals -1/2 x plus 2. Find the equation of a line passing through the points A, 5, -4, and B, 2, 2. Once again, we're not told exactly what the slope is, but by using our slope formula, we can use these values to figure out what that is. y2 minus y1, 2 minus -4, over 2 minus 5 gives us -6 over 3, which gives us a final slope of -2. Now we have enough information that we can plug it into our y equals mx plus b form. So we'll use this particular coordinate and this slope right here, plug it into our formula, and solve for b. When we're finished, we end up with a value of 6 for b. B is 6, slope is -2. We can write our equation. Y equals -2x plus 6. Change into slope y-intercept form. So in these instances, we want to get y isolated on one side with our 2x and 7 on this side. So we simply bring these two values over to the other side, giving us y equals -2x minus 7. Over here, again, we want to isolate y, so we'll keep the 2y for now on this side and bring the 3x and the -8 over to the other side. So we're left with 2y equals -3x plus 8. Divide both sides by 2 to isolate y. Gives us y equals -3x plus 8 over 2. We want to write these as separate fractions, so we end up with y equals -3/2 x plus 4. So this is what a positive slope looks like. Actually, let me restate that. We're asked to identify which one is a positive slope, which one is undefined, which one is a negative slope, and which is 0. Well, our positive slope is this one right here. Our undefined slope is vertical right here. Our negative slope is over here. And our zero slope is right here. Given the line y equals 2x plus 1, what would be a parallel line to 2x plus 1? Well, we have a lot of options. The only thing we need to worry about is, does it have the same slope as y equals 2x plus 1? We could write just about any equation we want, provided the slope was the same. So here's an example of a parallel line. The slope is the same, but the y-intercept is different. If we want to write an equation for a steeper line, all we need to do is we may need to make sure that this number is bigger than 2. So y equals 3x plus 1 would be a steeper line than y equals 2x plus 1. Given the line y equals 3x minus 4, write an equation of a line that is parallel to it. Well, as long as this equation that we write has a slope of 3, then it's going to be parallel. So 3x plus 1 would satisfy that. Question B asks us to write an equation of a line that is steeper. Well, as long as the new equation has a bigger number than 3, then it will be steeper. So here's an example of a parallel line to 3x minus 4. And here's an example of a steeper line than 3x minus 4.